So next one, we are going to see what is the gain bandwidth product. So we have derived two cutoff frequency F alpha and F beta, which gives an idea about how the current gain is going to vary for the common emitter amplifier at high frequencies. We are going to derive one more parameter called as Ft, which is defined as the cutoff frequency at which the amplifier is going to have a unit current gain. The current gain is 1. Current gain is unity. So we are going to derive one more frequency is called Ft. Ft is called as the cutoff frequency at which the current gain is unity. At high frequency, the current is dropping, right? So in that case, at some frequency, the current gain will become 1. So I'm interested to find at what frequency my current gain is becoming 1. So for that, I'm substituting F is equal to Ft. So this is the current gain equation you see, HFE by root of 1 plus F by F beta the whole square. You have complex numbers. I am taking modulus on both sides and I am removing all the complex numbers. Now, what is the condition here? I want to find Ft. So the condition for Ft is the current gain should be unity. So I make modulus of Ai equal to 1. I make the current gain equal to 1. Now you substitute current equal to 1 on both sides. So HFE by square root of 1 plus F by F beta the whole square equal to 1. Square both sides. So HFE square equal to 1 plus F by F beta the whole square. So adding 1 to F by Ft by F beta is not going to make any change. So I am neglecting this one. So I can write HFE by Ft by F beta is approximately equal to 1. Or I can write Ft by F beta is approximately equal to HFE. Or Ft is equal to F beta times HFE. So I am neglecting this 1 plus. So addition of 1 is not going to change my value so much. So I can write it as approximately. So here also you can see that Ft is F beta multiplied by a very large number HFE. So Ft is very, very large when compared to F beta. So Ft is the product of low frequency current gain HFE and beta cutoff frequency or common emitter bandwidth. So similarly, you can also prove that this Ft is going to be same as HFB into F alpha. So Ft, what we got here is for common emitter HFE into F beta. So similarly, if you want to derive the same thing for common base configuration, you will be ending up with a similar expression. Ft will also be equal to HFB by F alpha. The value of Ft will range from 1 megahertz for audio transistor. For audio frequency amplifiers using common emitter configuration, the frequency at which the current gain becomes unity is approximately 1 megahertz. In common emitter, actually the current gain is large, but because of high frequency operation, the current gain drops, and at one point the current gain becomes 1. That frequency is 1 megahertz as indicated here. And how did they arrive at this 1 megahertz? By conducting experiments for this audio transistor. By studying the frequency response of audio transistor, we can easily find what is the cutoff frequency Ft. And if we are going to go for high frequency transistors, this Ft will go up to 1 megahertz because of high frequency operation. The typical values of F beta, F alpha, and Ft are given here based on the experiments. So F beta is very, very small, 0.36 megahertz. F alpha is very, very large, 95.9 megahertz. And Ft is going to be 80.63 megahertz. So at 80.63 megahertz, the transistor will have unity current gain. The current gain is going to be 1. So output current by input current, that ratio is going to be exactly equal to 1. So remember, these three frequencies are very, 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 very important for characterizing a amplifier at high frequency operation. So if you substitute the expression, you can find everything, you can write everything in terms of Ft. So Ft is going to be HFE into F beta. So substitute the expression for F beta. So this is going to be F beta. So I am taking this R B dash E separately out from this group. So HFE by R B dash E into 1 by 2 pi into C B dash E by C B dash C. But HFE by R B dash E, I know it is going to be equal to GM. So this is going to be equal to Gm. So Gm by 2 pi into Cb dash E plus Cb dash C. So and among the two capacitance, Cb dash C is very, very large. So and Cb dash E is very, very small. So you can neglect that. So Ft will be approximately equal to Gm by 2 pi into Cb dash E, or Cb dash E is going to be Gm by 2 pi into Ft. So even if you want to substitute everything in terms of Ft, you take the current gain equation, Ai equal to minus HFE by 1 plus J HFE into F by minus HFE by 1 plus J into F by F beta. The substitute for F beta as Ft by HFE. So minus HFE by 1 plus J HFE into F by Ft. So this is the current gain in terms of the function of frequency in terms of Ft. Ft is going to be the cutoff frequency at which the current gain is going to be unity.